Hello and welcome to episode 37 of Cooking with Unity, where we're going to be doing some more stuff on pathfinding and getting the project a little bit more organized for our FPS. And Phil actually has some stuff to show us. He was working on some pathfinding stuff. He wrote his own implementation of A-Star.
I did.
Yeah, he was so inspired by the show last week that he's just like, hey, I found A-Star online. I'm going to fix that. I'm going to make it from pseudocode into C#, and he totally did it. He did it really fast, too.
Yeah, it took me less than a day.
Yeah. And so he's going to be showing off a few things with the node pathfinding stuff and editor stuff. But before we get started, I just wanted to say, I wanted to give a call out to CodingJar. So CodingJarGames.com has a blog, has a bunch of different stuff. He has a whole bunch of different Unity and coding related stuff. But importantly, he has just spent a lot of time making a really, really cool interactive tutorial for Unity. And he posted this on Reddit, and I asked him if I could show this on the show, and he said yes. So I just want to give this a quick call out. So what's cool about it is within Unity. So you download Unity, you download his little project, you open it, and it has all the tutorial steps in it. So I'm just going to hit play and just show you a few things. So
hello, and welcome to the CodingJar Unity 3D tutorial series. We're going to start by learning some basic scene manipulation. Let's get started.
Let's.
The first thing we want to do is create a cube. Look at the very top of the Unity window. You'll see a menu item named Game Object. Click on Game Object, then click Create Other, and finally click Cube.
So what's cool about the system is it actually waits for you to do it. So when you actually create the cube, it goes on to the next step.
I want you to rename the
and
cube
if you
to
get ahead of it,
capital.
so I'm going to rename it to Player.
To do this, first click on the cube in the hierarchy.
It immediately goes to the next
Knowing
step.
where your objects are in the scene
And
is extremely useful.
And it goes through a lot of
The
things, and it
player
shows a
using
lot of the
origin.
basic stuff.
The origin is another
I'm showing the
position.
very first lesson here, but it's really basic stuff. It starts, but it gets more complex, and it's really in depth. And he never misses a beat on any of the terminology. Like anytime that he's specifying the actual camera that's viewing this thing, I usually just say camera. He specifically says scene camera. He is very very articulate, and it has all the text here on the screen too. So you don't even have to have your audio on if you don't want to. But if you do, you are treated to an interactive tutorial. I really like this, and you should check it out. I'll have the website in the description link. So now that we've done with that, thank you CodingJar for making this. This is really cool stuff.
That's very neat.
So we're gonna open our new project, or not our new project, our project in progress. And I'm going to close this. This was from his little editor thing. And so here we are. So let's do a quick little rundown of where we're at before we get started here. I'm going to hit play. So we've got some basic stuff in here. We've got the ability to shoot, as we had before. We've got a little dude who's coming down the hallway here, and he will actually be following nodes that we placed in the level and pathfinding to try and find us. And so once he gets to our node, or close to our node, he will start chasing us. We're actually going to change this behavior on the show so he's a little bit more smart, because right now he can walk into a room right where he can see you, and he won't chase you until he's actually part of whatever node that you're a part of. And right now he's also pathing based on... Here, let me actually bring up the scene view so that you can see him moving here. Where is that zombie? So, oh, he got stuck on the wall, so he decided he needed to move towards me at this point. Let me move back here. So, oh. Yeah, so he's going to the node now, and then once he gets to my node, or close enough to the node, he'll turn and start moving towards me. But yeah, so he's working. It's a little bit quirky. We're going to fix that later. But I'm gonna actually switch this over to Phil now, and he's gonna show us how to make it easier to basically connect the nodes up, as opposed to having to manually place them and stuff.
Mm-hmm.
And he's gonna basically show off that system and talk to you a little bit about what he set up here. So anyway, I'm gonna hand it over to him.
Okay.
Just move out of the command chair.
Oh, command chair. Now I get the command chair.
You get the command chair, Phil.
Everything will be...
You are the commander.
All right. So, as I said, as Max already said, I decided to go ahead and make an A-Star pathfinding script. And I decided also that I wanted a system to auto-link the nodes. Musical cans. But anyway, I decided that I wanted a system to auto-link the nodes together because I am lazy. and I really like the idea of nodes talking to each other instead of me having to do all the work. So what I decided to do was make a script, basically, that started with an overlap sphere, and that is empty. So we're going to go ahead and open that. So I wanted a way to do it, and the first thing I thought of was to get an overlap sphere, basically, of all the nodes in the area. So let's see. For this, I'm going to actually need to change this to a list. So I'm going to use a public list, and it's going to be of game objects.
So why are you changing it to a list?
I'm changing it to a list because I'm going to actually need to dynamically change the size of an array. It can be start out as 0 and go to any number it needs to, and I can just add nodes to it. If it was just an array, it would be non-immutable, as we've discussed in previous episodes. But yeah, it's a good thing to go over. I appreciate the question.
Yeah, no problem. That's what I'm here for.
Yeah, that's
I'm your tech, Maximilian Rowe.
I guess that's true for right now. Won't be true for long. So anyway, I just decided to make this into a list. So I'm just initializing a list here at the beginning. I'm also going to need a radius of the overlap sphere. So I'm just going to go ahead and do that right now. So I'm going to do a public float, call it node radius. And let's set it to a value of 50 right now. It just seems good, I'd say. So we're going to have this on a different function, actually. It's not going to be on draw gizmos, nothing like that. But what this is going to be is a context menu item. So we haven't really covered that before, but these will add a little, basically pull-down menu on the top of these functions in here. Like if we go to node 1, you'll see this little gear. If you click on that, it'll actually add another component to the bottom of it. So that's what we're going to do this in. It's just going to make it easier for us to get a menu option to connect the nodes. And we're just going to go ahead and call it connect node to neighbors. Apparently I can't spell, which is always fun.
Not like spelling would matter on that anyway.
It doesn't, but you know, I'm gonna see it and I'm gonna look at it, and if it's not right, it's gonna make my skin
I'm not
crawl.
saying you shouldn't be consistent, and honestly, you should be consistent and spelled right so that someone else is being consistent doesn't cringe when they see your code.
That is true. So it's gonna be a void function. It's not gonna take in anything. And we're gonna call it find neighbors, and I almost spelt it wrong again.
I actually have that problem 30 times on the last
What,
episode. I'm not
Nate
sure if you
Bors?
noticed.
Yeah.
No, not Nate Bors.
Yeah, that's what I was doing.
I got like
Nate
the
Bors.
E and an I transposed every time. So
Fair enough. So first thing we're going to do on this script is we're going to go ahead and clear the array we just made, just in case for some reason there was stuff there before. So in that situation, basically, you know, just in case there is already an array of things there, we don't necessarily know if it's going to be the same size, or the list, I should say. I shouldn't say array, huh? But it was the list. But we're going to clear it.
same difference.
Neighbors, and we're just going to go ahead and clear it. Just like that. Pretty easy stuff. So we're going to get an overlap sphere right now. So for this, I'm going to have to make a new collider. Array, actually, and we'll call it col. Just makes it easy. It's a throwaway name, right?
Yeah, I'd put coals just so that you know it's an array.
Oh, okay.
To be
We can
consistent
do
with
that.
The previous show stuff, but it doesn't matter to
it's
me. I just don't know
coals
what
now.
you're going to call the variable if you have to iterate over it.
No, it doesn't matter.
Okay.
No, that's a good point. I would probably call it node.
Oh, okay. Well, so, yeah, there you go. Yeah.
Okay, so we're going to go ahead and do a physics overlap sphere to get these. Which will basically just put a big sphere that you can't see into the area. And we're going to put this at transform.position. So that's the position of the node, whichever node this is on. And we'll go ahead and plop in the node radius, which is the radius of it. And what I'm going to actually do here is create a layer mask. I'm going to go ahead and just put the name of it in here first. But, you know, we need a layer mask. Basically, the reason why we need a layer mask is because this overlap sphere could have any amount of objects in it. It could have, you know, walls, it could have players, it could have anything in it. And we are only really interested in the nodes. So we're going to have to create a layer mask for that, and we're also going to have to create a layer for the nodes. So we're going to get a layer mask, and we'll just call it nodes. Node layer mask.
Now, in that layer mask, you'll have to also have the collision geometry in there too, right? because it needs to
Yes,
check
it
against it to see if a wall's
does.
occluding or something. Okay.
Does it?
I think so. I don't know. Maybe I'm thinking ahead.
Okay. Well,
But-
we'll figure it out.
yeah.
We'll cross that road when we get there.
Yeah, absolutely.
Okay. So, let's actually go ahead and set these nodes up with that right now. Since also we're going to be checking for a collider in there, we're going to have to give these nodes a collider. So we're going to go ahead and give them a sphere collider. All three of these nodes now have sphere colliders, and we will get them a layer. So we're going to go ahead and add a layer and just call it node. So now they have a node layer. Well, they don't actually. We just set that layer. And watch me struggle with these. I think I just renamed a node, but it doesn't really matter.
How does that happen? I've had that happen before. When I just drag things around, it just renames them.
Yeah, it's horrible, isn't it?
Yeah.
Well, I mean, it's
All those are actually nodes, right? Okay, good.
Yeah, they are actually nodes. Here, I'm going to change it back to node 3, though, because I knew that's the one it was. So now all these nodes have the proper layer of node. And we can go into the script, or into the node right now, and set their... No, we can't. Oh, I didn't save it. All right, let's go ahead and set their layer mask right now since we're thinking about it. So we're going to go ahead and do the node layer mask as node, which makes it pretty easy right there. We're actually going to also need another layer mask too, but we'll cross that road when we get to it. So we're going to need to cycle through all of these nodes that it returns. So we're going to do for each loop and do for each collider, wrong thing, collider node in cols. So this will go through all the collisions, find out, or just go through them all. So we don't want it to try to connect itself to itself. So we're going to do an if node dot game object is not equal to game object. So it's just going to compare whatever node it gets and make sure it's not the current game object. Just so, makes it easy.
Yeah, connecting nodes with itself, I'm not sure if it will hurt the Dijkstra or AirStar, but it's very possible it could create a very bad situation in either of them, so I would avoid doing that if possible.
You don't want to really connect something to
that
itself.
circular type thing can cause problems, potentially.
Yeah, you could get, theoretically, something caught in an infinite loop of trying to pathfind to itself. I don't know if that's the case or not, but...
Neither do I, actually, for this moment.
It's better not to have that be the case. Yeah. So we're going to need to also get a raycast hit, because we're going to be casting a ray from node to node to see if they actually can connect. So I'm going to go ahead and put the raycast in there, since we will need it. Raycast hit, and we'll just call it hit. Works for me. And now we're going to actually need a raycast to do, and this is where we're going to actually need the other layer mask. So we're going to need another layer mask, and the reason why is we are going to have to check for collisions with a wall. So I'm doing this as a layer mask because if you don't do this and you don't actually check for any of this stuff, it'll collide against any object and be like, okay, I can't see the other node. There's no way I can see the other node if I slam into a player or like a monster or a wall. It won't know the difference between that or a activation object for that case. Like, like basically the monster closet that we have in here has a collider on it. So wherever that collider is. So the trigger here. This is actually something that a raycast would return as a hit. So we're going to need to also change that to ignore raycast. And I am very scatterbrained when I do this stuff, but it'll all come together fine.
You're doing fine, man.
I just had a brain fart. All right, we're going to need another layer mask, though. And we set that. Cool. So we're going to take these nodes. That's a sphere. That's not what I want. And I didn't save it again. It's a horribly bad thing for me to not remember. So we're going to only want a collision with a node, and we're actually going to go ahead and add another layer right now as well. We're going to add collision layer, which is basically any part of the terrain that we want to put as collision. So now these nodes need to know that that basically all the raycast is going to do is collide against nodes and collision right now, which is perfectly fine.
You may have wanted to put that in the... Oh, wait, you did. Never mind. I see.
What now?
Got it. Nodes and collision for the collision layer mask. Okay, that makes sense. Sorry.
Okay. So, right now, since it's in my mind, I'm going to go ahead and tag all the walls as collision, the floor as collision. All these things are collision objects, things that your player will bump into, and the monster closet as well, which really we only want the children, but we'll just change them both because it doesn't matter. So now we can actually, now they're all in a layer that is specifically designed to be walls at this point, which is probably a good thing. Alright, so now we're back here to the raycast. We're going to have to do a raycast. So physics.raycast. And we're going to need the transform position, which is the position of the node that we are on currently, the parent node basically. And then we're going to have to do a little calculation here. So we're going to take the next node position, the node that it's checking for, that's not the parent node, and get its transform position and subtract the transform position of the regular, or of the parent node. And this will basically give us a direction to shoot the ray in, which I think works okay. We're also going to need to get the hit info, so we're going to do out hit right now. We're going to need the radius, which is interesting because we're using a layer mask. It does need to specify a distance on the calculation. As long as we're using a layer mask, we need to have a distance for the raycast. So we're going to actually just go ahead and use the radius distance, since that should be the exact same length as the overlap sphere. And then we're also going to get the collision layer mask. So now, that is all we should need for that little raycast there. Yep, that's it for that. And then, now, I had a issue when I was going over this code on my end, because I actually did kind of prepare this ahead of time because I am not used to being the pilot here in this situation.
I should prepare ahead of time. That's actually to my detriment.
I actually don't agree.
Oh,
I think that
so?
it's actually
Okay.
better that you don't prepare ahead of time because it shows the learning process. But what I encountered was every once in a while I would get a null reference exception, and I didn't want that to happen. So what we're going to do is check for the null reference exception. So hit dot transform every once in a while, and this is not all the time. Most of the time it was absolutely fine, but every once in a while that hit dot transform would be null, and we want to make sure that that does not happen and it doesn't try to reference a null object. That's just
Actually, I have a speculation on why that was the case.
okay.
It's the case where the raycast actually doesn't hit anything.
Oh,
for
that
whatever
would do
reason,
it.
because it doesn't actually set anything to hit, and since hit is by default null, it gives you a null reference exception when you try to reference it.
Well, that works. Well, anyway,
So good, check for null.
yeah, we're
That's
just checking
good.
for null. And now we're just going to make sure if the hit transform game object, so basically we're going to get the game object from whatever this ray hit. And we're going to go ahead and compare it to the node that it's checking for. And this is just to make sure that if for some reason this ray goes off and hits something else, or like a different node that's ahead of this other node. Like say there were two nodes exactly in a straight line from each other, one right in front of the other, we really only want it to raycast to the node that it can see. We don't want to hit a different node. And that's just to make sure that it's actually hitting the right node. So that we're actually linking them up properly. And then at this point, this is why I actually have a list, is because it just makes this part so easy. All we're going to do is add the node to the neighbors list. And I think that is all of it for the coding actually part of this, which makes this pretty easy. So now, if we make a few more nodes,
You're welcome to create a prefab if you want to for the nodes too.
I don't need to do that
Okay,
right
all right,
now.
then just duplicate it.
All right,
I'll do that later.
go. So I'm not used to just using a trackpad. but we're going to go ahead and create a few nodes. Oh, goodness. How do you right? Yep, I don't know how to use trackpads.
Yeah, good call. Emergency backup mouse.
Yep. I can work much faster on a mouse.
I'm a trackpad junkie myself, but the only problem is there is no middle click on trackpad.
Yeah, and I love me some middle click.
It's the only time I notice a problem is when I'm trying to pan the scene. That's why you always see me panicking whenever there's a panning operation involved.
That's funny.
I usually just use focus and rotate until it's okay.
You know, that works.
Yeah.
So I'm gonna go ahead and create some nodes, as you see, and I'm just creating nodes because I love it. I'm gonna get all of these nodes here, all over the place. There's a little bit of rhyme or reason to them. Let's get them around the monster closet, just so it can pathfind around that thing. I think that's probably good enough, don't you?
Yeah, it looks good to me.
Okay, so we got nodes, and they're all still referencing each other, which is maybe not the best thing in the world. So we're going to go ahead and fix that. I'm going to select all of these nodes and go ahead and click on this node script. And see, now we have this connect nodes to neighbors.
That's literally the script he just wrote.
Yeah, I just wrote this script. This is all that this is it just added this little function, connect nodes to neighbors. And when we click on that, it actually auto-connected all of the nodes together. Every one of these nodes now is connected at the right distance. They're at 50. Now, say for some reason we only wanted them within 25. Now, this probably won't get all of the nodes, but say for some reason we wanted this. Now, if we did this again, as you can see, the nodes are not nearly as connected.
Sparse. It looks like a spider web who's on like weed or something.
Yeah, it does. I mean, I don't even know how this monster would get to where it was going right now.
Yeah, it wouldn't. It would be like, yeah, I'm here and I'm happy about it.
So basically, what this does is it just does an overlap sphere and it just measures what's inside of there and connects anything it can within that sphere, which I actually think is pretty cool. So let's set it to 70. What happened? Why are the collision? Okay, we're just gonna go ahead and add that again. So let's go ahead and connect it to neighbors, and now it's an even bigger spider web. But I'd say that works pretty well. And what we will end up running into a problem with, actually, there are two potential problems we're going to run into, and I'm going to hand it over to Max at this point. We are going to run into a problem where the player is going to collide with these nodes now because they have collision. So we're going to have to do some layer work where the nodes don't collide with anything. Yeah. And we're also going to have a problem where the projectile, because we can shoot these monsters in this game, projectiles can potentially go through those nodes right now, or go just collide with the nodes and not hit anything.
Okay, I think you're going to be interested to see how I end up solving both these problems.
Yes, I'd like...
Yeah, because I don't think I'm going to do what you think I'm going to do.
Oh, okay. Well, anyway, that was my little code segment.
Thank you very much. That was awesome. That was awesome.
You are welcome. I'm glad to help.
That's your first time on camera addressing the internet, right?
Yeah, well, for the most part.
That's awesome. That's really awesome.
On camera addressing the internet,
You
yes.
said way less than I do, so we get to see
Did I?
how... Yeah, you did great.
Oh, I had no idea. I wasn't thinking about it.
That's the key. That is the key. All right, so
now we got that spider web.
So first off, I'm going to change my trackpad here because we have opposing ideas on what constitutes going left and right. So we have this cool script, and so let's actually. So I'm going to hit play, and we've already seen that the monster AI doesn't work very well. And actually, let's fix some of the collision issues first. So we have this sphere collider. I'm actually going to not change what it collides with. Like we could go into edit, project settings, physics, and uncheck boxes to our heart's content. And that's a good way of doing things, and we may have to do some of that later anyway. What I'm actually going to do is I'm going to take all these nodes, and I'm going to change them to trigger colliders. Now, this doesn't solve the bullet problem because we're using raycast for the bullets, and I'm gonna point something out here. In the physics section, there is this raycast hit triggers. If you turn this off, it means that in all cases, triggers will never accept a raycast. In my experience, you almost never want to turn this off because there's a lot of flexibility where you might need that raycast into a trigger for some particular reason, and if you don't have that on, you won't be able to do it. If you turn this off early in your project, and then later have to turn it on, you will have to rehook up a lot of stuff just to get the collision to work the way you expected it to work. So just leave this on. I almost never should you turn this off unless you know exactly what you're getting yourself into. So that would be a way to solve the problem.
That's a rather generic, generic thing to do.
It would be a way to solve the problem, but I like having that as an option.
Yeah.
So what we're going to do, we are going to have to do some layer mask stuff so that bullets don't collide and stuff, but we'll get to that in a second. I'm just going to start with the triggers because at least that will make it so physically these things have no collision. You won't be able to run into them. It's just like our trigger on our monster closet. We can walk into that and it doesn't stop us. If we were to actually turn off the trigger, it will literally stop the player as if they were hitting collision. So let's start with that. And let's start, I'm going to change up the AI a little bit. We're going to need to, because of this new configuration, because of the colliders, but we're also going to need to do it because his AI sucks right now. So that's the honest truth, it sucks. So we're going to go into scripts.
He likes to run into
I'm actually
walls
going
currently.
to finally put these in the proper scripts folder. I always forget to do this for some reason.
So we all forget to stuff like that sometimes.
It's just organizational stuff. Sometimes it's nice. I kind of do that intentionally, just because I know what I'm working on. Then I kind of have it as a brain cache for what was the last thing I was working on. So, but then I put it in the script folder and then never can find it again. So we're looking for zombie AI. We're going to look at his little script. So what he's currently doing is he's finding the player, checking to see if he's in the same node as the player. Which in the node we're going to have to also change node, current node, which is what contains the node metadata. That's probably not a perfect term for this, but it's basically for the nodes themselves are the nodes. Current node is for a game object to keep track of what node he belongs to. And so the way it's working right now is on start it does set current node, and on update it does set current node, and then it just basically finds whatever node is closest to you. That's the node that you belong to. This is actually very appropriate for the player, but it's not appropriate for the monster, because the monster, basically, you have to node things really awkwardly if you want him to actually go into the hallway and turn to get to the player. And the other thing is, when he's in the same room as the player, like in rooms you're going to have nodes, potentially. You're not going to just have a node in the middle of the room. You could, I'm not saying you couldn't do that, but in the case of multiple nodes, he's going to try and get to your node before he starts chasing you, when he actually should just start chasing you the moment he's in the room. So that's
the moment that he has eye contact.
The moment that he has eye contact. We're not going to do eye contact. We're just going to do can he raycast to you? This is what we're going to do. And we're actually going to do a sphere cast, which is the same as a raycast, except for it's wider. It's just think of it as a cylinder cast. Really, is what you should think of it as.
Really, that might actually be better for noding. Actually, too.
It's no, for the nodes, the raycasts are fine because you're going directly to it.
Yeah, but you could have a situation where you're right next to a wall.
Good point.
And that the monster would get hung up on the wall. So a sphere cast might actually work better.
Yeah, no, you're right. You're right. That solves it. Because actually the reason I'm doing this is because we want it to... So if he does a raycast, there's he'll edge the wall and he'll kind of collide with it. But if he does a sphere cast, we can use the width of him to do that.
That's a good idea.
So we might add that to the node thing.
I think we should.
We'll look at that. We'll look at that.
Sorry, I was just thinking out loud, and that just popped into my head.
No, please think. That's what this show's all about.
What?
What? We have to think? Oh, crap. I'm on the wrong show.
That's so difficult.
All right,
Thinking's hard.
So what we have here is, if it's in the same node as the player, chase player. We're going to change this. We're going to actually change this. We're even going to change the comment. We're going to say, if the dude can be seen, I'm going to put it in quotes, seen via raycast, then chase. So we're no longer going to check to see if the current node equals the current node or whatever. We're going to instead do a raycast. I'm going to leave this if statement in there. Physics. So we're going to need a out parameter here real quick. So I'm going to create a raycast hit. You called yours hit. I'm going to stick with hit.
Yeah, I mean, it just...
I usually do info just because they call it info in the constructor. I don't know why I do that. It doesn't matter what you call it. You could call it smorgasbord.
Oh, smorgasbord's a good name.
It is, but it's so long and hard to type, so I'm not doing it.
I don't blame
And it's
you.
not very accurate. Hit's probably more accurate than what I usually use. So if physics.raycast... Actually, we're going to do spherecast. We're going to just go right for the spherecast. So
I think so.
spherecast. Whatever. Spherecast. There we go. Oh. Spherecast doesn't start with SH. Speaking of spelling,
Yeah.
I don't know where that came from. All right.
You know, I tell you, just as bad for me. So.
Yeah. No, exactly. The brain just goes out the window as soon as I get in front of this TV.
This
computer.
yes, the TV.
What's a TV? Have kids actually started saying that yet? Because I feel that that's coming.
Oh, it should happen soon.
So we want a spherecast that's like origin, radius, direction. That looks good. Out rate. That's exactly what we want. So origin is going to be our transform position. So we're shooting array from the dude. Our direction is going to be actually our radius first. So the radius is going to be I'm going to actually put a public float sphere cast radius as a thing here, and we're going to default it to 1.0f. I think he's 1 unit wide, so I'm just going to go with actually radius. So
it would be
let's actually do
0.5.
0.5. Yeah, 0.5, because the radius is half the diameter, and he's not spherical, but he's wide enough that we can work with us. So if physics.spherecast transforms spherecast radius, and which one do we want again? We want the radius, direction, hit info. So the direction is player.transform.position minus transform.position, and then the layer mask, which I actually can just leave that blank. We're safe on that.
Yeah, it doesn't really need a layer mask.
Yeah,
Well,
it may actually. We'll see. We'll see how we hook it up.
Yeah.
It depends on how we hook up the collisions for nodes and stuff. So I think I'm going to solve that with the physics matrix thing. So so here we are. We got the sphere cast. So if it's successful, we need to check to see if hit is actually the player. So if hit dot game object dot tag dot collider dot tag.
I know
equals player.
It's kind of like that sometimes, messing with code, isn't it?
And actually, that should be a word,
Is it a
string
capital P?
literal as opposed to. And it is capital P, and I think that does actually matter. So then we just throw all of this stuff in here, and it should just work. And finally do that. Make it all nice and neat looking.
Make it pretty.
And so let's start with that and see how he operates. So we're going to go ahead and hit play. Oh, compiler errors. The best overload match for physics sphere cast. Ray float has some invalid arguments, so it doesn't like my thing. Oh, I don't have.
Yeah, you need parens, yeah.
I need the out raycast info. So out hit. There we go.
Yep.
And this console should be docked over here. I don't know what it's doing, floating around.
Oh, now it's floating around in a different space.
At least it's not like the first episode where anytime I did any of this, it didn't show up on the video.
Really?
Yeah, it was horrible. I used a different setup for it, and it's a terrible episode, actually. It's not a terrible episode,
No,
but
it's
like,
not.
and everyone comments, it's like, oh, this is so great. They get to the first episode, I'm like, oh, thank God they thought it was great, because it gets so much better afterwards. Like,
Yes.
episode 10 is where it gets good, because it gets HD at that point. So,
I just figured the episode where I started getting there was when it was good.
oh, yeah, okay, like,
I'm
episode
joking.
400 whenever you came.
Oh,
in.
400! I see how it is.
Oh, yeah, you know it. You know it. So, sphere cast, Unity Engine, Vector 3 float, Vector 3... Okay,
What's
so
the
what does it
problem?
want for it? So let's see what it actually wants. Physics.spherecast. Got a origin, radius, direction,
Hit info. That should be it. That sounds like it right there.
That's
Oh,
origin.
transform.position. That's what you need to add there on the sphere cast. It's just a transform.
Thank you.
Dot position.
Thank you.
Yep.
Thank you. That's what you're here for.
Yeah, I try.
Fix all my stupid shit.
I try.
All right, so we hit play. All right, so I think it's working now.
Now we're going to see if my nodes even work right.
I'm sure that they're fine.
Oh, that's what you think now.
So I'm going to go ahead and split the scene view again so that we can see what the dude's doing while he's all the way far away.
You could even show the gizmos if you wanted to on the while in game.
Okay, so he's not doing anything right now.
Did I hook things up wrong?
No, I think I hooked things up wrong. All right, so zombie AI.
You should turn on the gizmos to see if he's pathfinding even, if the pathfinding's working.
Well, I mean, it's not going to show anything, but
I thought it would.
Well, I don't think I have anything magic
that
shows
not
that stuff yet.
Yeah.
We may add that in a second to debug this problem. So he's not moving. Let's see if he moves if I move so that he can see me.
That's a good idea. All those lines.
Oh. My logic is dumb. So what I'm doing here is I'm checking to see if physics sphere cast. So this if statement is actually to protect from this being null. Actually, this is how you usually set these up.
Oh, okay.
Because this will return true if it hit something.
Oh, okay.
Which means if it hits anything, which it's going to, he's going to go to this else statement. He's not going to go to this else statement. He's going to go here. But it's not the player, so he's going to just sit there on his butt. So we need to actually change this else statement to be within.
Well, you could change that in my logic, actually. That would be nice.
Yeah, it may actually fit better in your logic. So wait, we want this to be in here, but we want this to go even if the sphere cast doesn't hit anything. So I'm actually going to just use your method. We're gonna pull this out of the if statement, just like yours was. Yeah, because think about how I'd have to reset this thing. I'd have to basically duplicate this code in two places, and I don't want to do that. And I don't want to create a function because I'm loath to do that. So we do this stuff. We bring this back. We get rid of this one, and then we just throw a quick
semicolon.
Slap on a semicolon here. Thank you.
Yep.
Because I pulled that out of the if statement. And then finally, let's also check if hit equals or does not equal null.
Yeah.
That'll work. So we just encapsulate that here. Oh, wait, that's still... Actually, let's put this inside of that. There we go. That'll solve all of our problems. Wait, no, that doesn't solve all our problems.
No, it doesn't. But you can encapsulate it right here. So just put the if collision doesn't equal null right there. Oh, sorry.
If collision doesn't equal null, where?
Above, where it was before. And then just put the end bracket before the else.
Yeah, but then it only goes to the else if it equals null. See the problem?
Oh, yeah, that's a good point.
I'm not going to worry about that error for now. We'll fix that in a bit. Because I'm spending too much time on some trivial stuffs here. So let's hit play and see if the AI starts doing something. Oh yeah, he's doing something. He's breakdancing. So he's cruising.
He just turned around.
Yeah. And so now once he gets into the room, he should start heading towards us. Let me actually, I wish there was a way I could just follow him easily. I'm going to zoom out so that we can see his pathway a little bit better. So he's going to round the corner in a second here. I should have moved him closer. Actually, I can do that right now. Just move him closer. So he already started going towards me, didn't he?
Did he already?
No, I think he's trying to get to the other node. Okay, so that's the other problem. We're using the really stupid logic that I put in there in the last minute of the last episode. So right now his logic is basing his current node on the shortest distance, which means that he doesn't get to the nodes and then go to the next node. He gets close to the node and then changes to it, which is really hard to deal with, and we don't want that. So we're going to change his logic. But we want the player to still be set on the current node because the player is not following the paths. The player can't even see the paths. In a perfect world, actually, maybe that would be cool to have a game where you can see the paths. But most games, the player's not going to see all the paths that the units can take. But the units need to know what current node the player is closest to. So this logic will still stay here. So I'm going to add a public bool. is AI is what I'm going to call it, because is player would work. We could work with that, but the truth is all AIs are going to want to use more down-to-earth node-to-node logic, and the player is not going to be bound by that. So is AI, I think, is a more descriptive term.
Oh, absolutely.
So is AI, and I'm going to default it to true, because we're going to only have one player, and so the defaulting it to is AI is true is more useful as a default value.
No, I agree.
So we're going to go ahead and change this to if not is AI. We're going to encapsulate this in the brackets and go ahead and select it and hit tab to bring that out. And then we're going to go, oh, I didn't get this one out there. And else, now we have to write our new logic. So actually, I'm not even going to do an else statement. So start set current node if is AI. Oh, okay. I'm actually putting this in the wrong place.
Yeah, you were thinking the other way around.
No, actually, I'm thinking it doesn't go in there at all.
Oh, okay.
So in the start we always want to set the current node. So that way you don't have to place enemies directly on a node for them to work.
Correct.
But during the update, we're only going to set current node if it is not an AI. So if not is AI, set the current node. Now we have our else statement. Else. And so here's where we put our new logic. So I may not even put anything in here, because what I'm going to do is I'm going to make it so when the unit enters a node, they instantly become part of it. And this way we don't even have to check up every update loop. We don't have to do any distance calculations or anything for them. So what we're going to do is we're going to do void on collision enter. And from here, we're going to check to see if, so we need a collider col is what I'm going to call it. So if col dot tag equals node, we know we've hit a node, so we should set his current node to the node that we just hit. So all we do is current node equals col dot game object. So now this guy automatically updates his position. Now we do still need a special case here. So this handles the case where he's following the path. We need to have something where we need to have some logic somewhere that sets his node to the nearest node under the event that he has gone back to his AI behavior, because we can basically pull him off his path, and if we pull him off his path, he will be lost to us at that point, or he'll return back to the node that he was at, which is really weird looking. So what I'm going to do is I'm going to actually set the else statement here to, actually I'm not even going to have it be an else statement, I'm going to have it be a separate statement. If, actually I'm going to have it in the if statement here. If is AI, not is AI, or current node equals null. So this will reset his node if it's null. Now it still has to become null at some point. We don't have any logic that actually makes this thing equals. Yeah. We're doing a comparison, not as an assignment. So we go into zombie AI here, and I'm going to basically set it so if in the event that it can see the player, at this point, it sets this stuff to null. And it'll be setting it to null every frame at this point. We don't really care about that. There's a little bit of overhead. It's not going to hurt us. So if, actually, we don't even do an if. We just, at the end of this, I'm just going to say, zombie AI, we need his current node. So game object dot get component current node. Whoops, I don't need this extra thing there. Current node dot current node equals null. That's kind of awkward, this current node dot current node, but that's how I set it up. So now that sets it to null. So now this logic will just be like, oh, it's null. Let's reset his node. Let's make sure that he always at any given time has ownership of a node. Now, I said that I'm resetting this every frame, or you could optimize that. I almost wouldn't optimize that just in case you decide to make logic later that relies on his node when he's off the base.
Yes.
And so you want him on nearest node if he's not on a node, but if he's on his path, you can rely on him staying on his path.
I think that's good.
So let's see how this works now.
Can you do me a favor real
Sure
quick?
thing.
Can you go back to the node AI and just slap on a sphere cast instead of a ray cast for that?
Yeah, why
that
not? Why
function
not?
I
Let's
did?
do it. So we're gonna do sphere cast instead of ray cast. So we're just gonna call this sphere cast.
Yep. It's a capital C on sphere cast.
Why?
Just is.
But that's inconsistent. How horrible of them.
That's what it is.
Because it's lowercase on raycast.
I don't know what to tell you.
I didn't write it.
And
so we need a
to do is
radius.
add a radius after
so
the
yeah,
first
let's
position.
go ahead and add a public
Float?
sphere cast radius.
That's what I did.
Sphere
I just
cast
modified my
radius.
codes after hearing about
Yeah,
the
he's
sphere cast.
he's like, I gotta have that in my game. Like he's so excited to have pathfinding, and I'm so excited to have pathfinding. Actually, I've been playing around with this stuff all week actually because it's just cool. And I'm excited to what we are going to do on later episodes with this because we're going to build on this stuff. So,
and what's nice about this pathfinding for yours and mine is it's portable. So like we could take that code and just slap it into any future project we have.
So ironically, because the sphere cast is set up differently, I swear that we actually don't need the node radius now.
We do actually. The node radius is the distance.
Sphere cast. No, but I'm saying that sphere cast doesn't have that limitation.
I don't know if it does, but
Like,
it asks for it.
Origin, radius, direction, hit info,
Distance,
distance,
and layer mask.
You're right. Okay.
Since we
I was
have a
wrong.
layer mask, we're going to need that still.
Okay, so that's fine. I'm not going to change it. So that's probably all we need is just the radius right there.
That is.
All right. I should
So
have
now
just
let's
trusted you on that.
Let's
Because you had just been playing with it.
should recalculate those real quick.
Okay, just make sure that these actually work.
Yeah.
Okay, this will be interesting. Actually, this one should not work because
Correct.
of the sphere cast. So
Yeah, I'm very
did I actually
interested to
set
see
a
that.
default rate. I didn't. I'm an idiot. I am, and I've already compiled. No, I have to reset the values. 1.0 f for the sphere cast rate. Oh, sorry, 0.5 f. But then we're actually going to have to set it on all the nodes because these ones are going to have the default value from when it compiled. Oh, maybe it didn't compile because I have a script error.
That's possible.
What's the error?
Wait, what was the error?
Script error on collision. Oh, sorry. The reason I did collider is because on collision error, yes, you need a collision, not a collider. But this is actually on trigger error because all these are marked as triggers.
Oh, that makes sense.
So now that script error should go away.
Let's
and
see if the
hopefully
nodes-
the nodes will have compiled later.
They did
so
not.
They did not. All right. Well, they compiled first. So we're going to just set this to 0.5. And that'll be simple enough.
And
so now we're going to give this a shot. We've got all the nodes selected. We're going to connect node to neighbors.
oh god,
Oh,
that just destroyed it.
I must have done something wrong.
Whoa, what was the node radius there? Look at that.
Oh, that's a very small number.
Yes, that is.
Yeah, let's make. What was it originally?
75, I think.
Let's do,
It
let's
was
do
50
The
originally.
75 because we want to. That case was only there in the 75, so I want to make sure that's there. All right, so now that that's 75.
Oh, and make sure that the collision layer mask is right for node and collision.
Okay, let's just do that. Node collision.
And it still says mixed for some
That
reason.
mix is fine. That just means that it's too lazy
All
to
right,
show it.
that should be everything.
All right, so now we hit connect node to neighbors.
And it still didn't work.
What did I break?
I don't
You and
know.
your sphere cast.
Maybe I broke it by
You and
asking
your
to do the
sphere
sphere
cast.
casting. It just made more sense.
Yeah. Let's look at it. So we've got our nodes out hit. That is in the right position, right?
It takes a raycast hit, right?
Yeah. Let's see if it's even getting in here. I'm curious. You go ahead and look it up to see if that's moved positions for whatever reason. So I'm gonna hit. Oh, I need to actually hit debug. Unity editor, attach. So let's see if it actually gets to here at least.
Well, it looks like it's the
Connect
sphere
node
cast is
neighbors.
broken. It needs a raycast, I guess.
Okay, so it did get there. Get.transform.game object equals
Huh.
node game object.
Well, I apologize for that.
Why would that not work?
I
It
do
should
not
totally
know.
work. I'm gonna try it again. Give me it.
Because I
Do
just
it.
tried it on my code and it didn't work. Too.
It didn't work on yours too?
Nope.
Okay.
So it must be
I'm
something
gonna go
with
back to the
sphere
raycast. I'm gonna go back to the raycast because it was working.
Yep.
We'll fix that later or something.
Yeah, I'll look into that right now, actually.
And actually, I'm just going to make the radiuses 50 so that that long connection doesn't happen. 50. Oh, it doesn't have it doesn't have one for ray cast with a capital C. It has one like that for sphere cast.
Yep.
Whatever. All right, so just so you know, like these are the problems that other people are going to be complaining about your code later when you have things inconsistent. So don't publish your stuff unless it's nice and tidy. And I actually am pretty enamored with Unity's tidiness for the most part.
Oh yeah,
but
that's great.
but sometimes you gotta just I call it as I see it. So we got those reconnecting. That's just so sweet. I love that. Actually,
Yeah, I
one of
do
the things
too.
you didn't show is you can actually connect them individually. We select all of them, but it's actually like if you just wanted this node to figure it out, like if you just pick one node, you can just do it, and it'll just do that one node to the nearest node. So it's actually a really good designer tool. So if you're just like I want this node and I want it to connect to whatever, and then you can manually connect things as well. This doesn't
And you could have them
upset
different
any of that.
radiuses.
Yeah, exactly. You
as
could set
well.
you could set each individual node to a different radius, which is appropriate. And so this is super nice. I'm just gonna go ahead and reconnect all of them though now. Now that I showed you this feature that we're just gonna absolutely ignore. So
That's
I'm gonna hit
quite
play.
a spider web of.
Oh wait, that's
They're at 75 still.
75 again. Let's go to 50. Connect node neighbors.
Bam.
There we go. That looks pretty good. So we're gonna hit play. Actually, before we do anything, we're gonna make our zombie a hell of a lot faster because I'm sick of waiting for him. So zombie AI, we're gonna make his speed 4.
Wow.
So he should cruise now. His turning radius is still terrible, though, so we'll see what that actually does. So here he goes. He's cruising down the hallway, and I'm just going to sit here. I'm going to be like, oh, I'm over here. I wonder if there's a bad monster that's behind that door. Oh, he sees us, and he's going right towards us. That's awesome, and now he'll follow us around like we'd expect.
He's coming right
He's
for
going to
us,
have a
Ned.
terrible turning radius. Now I'm going to be able to get him real good in a circle. Yeah, he can just circle around us all day. All right, but let's actually play that again.
Oh,
I'm
that's
going to hit
ridiculous.
play, and now I'm going to actually occlude with this geometry, so he can't see us. And you'll see that he'll actually path around the geometry. So like this all works. It's really cool. So you'll see he gets to that node, and he actually chose the next node, and so this should be the next closest node to get to our position.
And now he saw you.
And now he saw us, so let's get him behind the wall again. And now he goes back to the hunt, and then he sees us. So he does kind of wheel out a little bit, but that's good. That's good. So now he's like, okay, well, I guess I got to go this way, and then I see you now. So we have a
That's
character
pretty cool.
that actually is smart. He actually will figure this out. And actually, because we're doing a raycast, if I activate this thing, he'll actually raycast through it. So now he'll path right through the middle of it, even though there's no noding or anything there. Just because he's like, go towards the player, I can see him.
Yeah,
So-
and the actual object collision is up
Yeah.
in the air right now too. So
now let's kill this guy. Die! Oh god.
oh, that reminds me, we need to make sure that the bullets go through those.
Yeah, right now
circles.
these do not go through these circles. So because we're getting the raycast thing, so we cannot actually shoot through those. We can shoot around them. We can shoot around the squares because the squares actually just show where it is. But yeah, so let's fix that. So to fix that, invalid operation exception operated not valid due to the current state of the object. Oh, okay. We don't handle the empty stack or a null stack. So I'm ignoring that for right now. Oh, screw it.
Gonna fix it.
Yeah, why not? If path does not equal null, I'll fix that. And we do all this junk. If path equals null, then he doesn't do anything, probably. He'll never figure it out. It won't change his goal. Okay, that'll be fine.
Oh, that's interesting.
So let's make sure that didn't break anything real quick. while I think about what we're doing next.
Apparently,
So,
this is good to know, but sphere casts do not work against colliders configured as triggers.
I think that's the reason I was pulling my hair out on Proton Pulse at one point. Wow, that's it's horrible.
Yep.
All right, looks like he's still working. So I
But
think
that's just something that I found out.
All right, so sphere casts don't work against triggers. Why? All right, whatever.
Don't know.
I don't care. I'm gonna merge these windows again. So so what we're going to do is we're going to fix that raycast problem of not hitting it. So all we're going to do that is in our shooting raycast shoot. There we go. We're just going to add a layer mask to this. So public layer mask shoot mask. And I'm just going to make it so it doesn't collide with nodes. So we can go into our player. First person controller is our player. And we can go into our raycast shoot and we can change the shoot mask to, and I'm going to have to actually change it's not using this yet, but we're going to just set this up first. So we just want everything except nodes. So I'm going to go ahead, I'm going to save the scene because we should have done that an hour and a half ago. Actually, how far are we in? Okay, it's about 47 minutes or something.
There was that little...
Yeah, we had a
technical
bump.
like...
We had a bump.
Yeah.
Don't look at the clock.
Now they're gonna look at the clock.
Now they're gonna look at the clock. Whatever. Yeah, now I can't be right about what I said earlier. Which I honestly I screwed myself on this one because I was like, no one's gonna notice it.
Curtain just pulled back,
and now everyone will look. Will look. They'll be like, what about the clock? And then they're gonna be really bored when they find out that it just jumps at some point. So,
yeah.
So don't waste your time. It's not exciting. So
spoilers. It's not exciting.
Yeah, spoilers. Do not waste your time on this. You'll hate us. So we need a raycast, but we actually care about the layer mask, so we just add our layer mask, shoot mask. So now, if we go back in here and turn on our gizmos, we should be able to see our little dudes here, and we should be able to shoot as if they weren't there. And that's
not the case.
Oh, it's not working at all.
Wow.
I must have done something horrible. Maximum distance must be greater than... Okay, that's obviously I missed one, so... You
need a distance.
We have array. So it's array, distance, layer mask. We need an out as well. Ray, out, distance, ray, out.
Yeah, you just need distance and layer mask.
Distance, layer mask. No, where's... There it is. There we go. No. So we want ray... We want hit info. And then we need layer mask as well. So we need something with ray, hit info, and layer mask. Ray, hit info, layer mask. There it is. There it is. Yeah, we need a distance in here. So mathf.infinity. Who cares? that's the equivalent of who cares. And layer mask is shoot mask.
Okay, now that should work.
So this should compile now and be happy. Hopefully. Oh, that's actually a runtime error. It was somehow parsing that in some way that meant something to it. So yay, it's shooting through that. You can see that it's actually applying the decals on the floor, and yeah, it's all working. So
the zombie found you.
Joyous. Oh no, it's the zombie. All right. So
you could theoretically visualize the path that the zombie was going to take too on the gizmo.
Yeah, let's go ahead and do that. Let's for the sake of being complete, and also for the sake of if you have a problem and you add this code, you'll be able to check it a lot easier. Let's add an on gizmos, on draw gizmos.
Yeah, void
on draw gizmos to our zombie AI, and let's actually be explicit about this so that you can see kind of what he's doing. So the zombie currently doesn't care about the whole path, so I'm just going to show his goal node. I'm not going to show the whole path. Or do you want me to do the whole path?
It doesn't matter.
I have to rewire things.
Yeah,
we'll start with just
the
goal right now, and then we'll maybe rewire it later. So on draw gizmos, we have we have this goal. We don't have it as a global. So all I'm going to do is, Yeah, I'm just going to do the goal for now. So we have this game object goal. I'm going to actually just grab this, declare it up here. I'm going to go ahead and make it a private because we only care about it internally. And we can just set this to goal path.pop. Now we can actually get at our goal in our other function here. So we're going to draw a line to our goal. So gizmos.draw ray. Hold on. Yeah. Gizmos.draw line from 2. So it's transform.position and goal.position dot transform.position. And then let's also draw the, I'm going to show you how to use this debug stuff so it's a little bit more useful. Let's draw our raycast to the player as well. We're going to actually start it out as green here. So gizmos.draw, gizmos.color equals color.green. So now we're going to go in if we can raycast to the player. So we're going to check to see sphere cast. We're actually going to do the sphere cast. We can't draw a sphere cast, unfortunately, but so we're going to have to draw a line, but that's okay. So we're going to do if physics.sphere cast. Actually, no, we're going to do this whole logic here. So, and we need raycast hit. So all of these things. And so if it collides with the player, then we set our, well, actually we'll just keep the colors already green, so we're going to just do gizmos.draw ray. I'm going to go ahead and do ray, and then we're going to do, so yeah, from direction, so it works just like the other thing. Honestly, draw line is probably exactly the same when we use it this way, but that's okay. So transform.position. And actually, I'm going to pull this out of here. Actually, I'm going to do that afterwards so you can understand why I was going to pull it out of here. So transform.position and the goal. So that's the player. Oh, direction. Oh, let's just do the line. Yeah, draw a line. That's better. Because then we don't have to do math at all. So transform.position and our player. We don't have the player, so we need to get the player as well. Bam. Player dot transform dot position, and then else. And this is why I'm going to drag it out. Like I said before, we're going to set the color to red to signify that it is not actually hitting. But we get to see the raycast anyway, so that we can see what's going on. And actually, let's go ahead and do it to the hit location. So we're going to draw color red. Actually, let's do it to the player because then we can see it clearly. So I'm just going to put this. We don't even care. So I'm just going to make this a little bit cleaner. We're just going to set it red if it's not going to hit, and then we do the same cast either case. So we're just going to do red if not equal to player. Sorry about all the reorganization there, but sometimes you got to reorganize. So now if we hit play, and we turn our gizmos on. So I'm going to turn the gizmos off so you can play it clean, but turn gizmos on, you get everything. So this ray is the ray to the player. So we can see his view distance, and you can see the green line there. I should probably make it a sphere at the end. And so now it turned green. See when he shows it, it still shows the thing that he would be pathing to now. Actually, I guess it's the last thing he'd be pathing to. So if we break the line, he'll recalculate. And I just failed. I just made it so it's very hard to break that line because it doesn't reset. Oh my God, he's fast. So really he's terrifying fast. So let's actually do it from. So I want him to see me around this corner, and then I'm going to not enter the trigger and raise the platform, but I'm going to occlude the platform. So So here goes.
He sees you.
Sees me. Now he doesn't see me.
Not see you.
And you can see that the green line changed to another node. So now he's going to that node until he sees me. And then he'll choose another node after that if he never gets to see me. He'll just keep circling around here until... Oh, he had a problem.
He got to his goal. It didn't set a new one, but
Operation
still didn't
not
see
valid
you.
due to the current state of objects. The stack is... If path not equal null, path.pop. What's the state of the object that's wrong? It's just continually saying that. Okay, we have a bug. I'm not fixing that on this episode, but we'll get that. I'll investigate that one and see what's going on. I'm not actually sure what he's trying to pull here, but he's trying to pull something, and that's the reason I'm going to pull the trigger. Yeah. Oh yeah, you're running from me. Why are you running from me?
He doesn't see you for some reason. Why wouldn't he see you from right there?
What are you doing? What is this?
I do not know.
Why are you being so naughty? Huh. Glad we put all this debug stuff in here because we're going to need it at next episode when I go through this. All right. Yeah, I'm sorry, folks. I am saving this for next episode. Just because I don't know exactly what's going on here, and it's near the end of the episode anyway. So apologies that there's some broken stuff in here, but for your homework, fix it. So I'm assigning you homework. This is officially the homework. Fix this and send me an email at pushypixels@pushypixels.com. Yeah. So that's where I was going to do this anyway. Let's wrap this up. So thank you for watching. It was a really great episode. Thank you for doing some work on this, Phil. I really appreciate it. I really appreciate you getting in front of the camera and everything. We're even going to show you.
Oh,
you guys already saw him, actually. I need to not act like this hasn't already happened because it technically has.
That is true.
Even though the editing process has not happened, post-production is fascinating in that way.
Because it's post-production.
Yeah, exactly. We've got to do it in post.
Not pre-production.
Yeah.
There is pre-production, though.
There is.
Not post.
There is.
Yeah.
So, thanks for joining us. PushyPixels at pushypixels.com. At Dracfire is my Twitter. Love to hear emails. And
if you want to send me an email, send it to Philip at protosoftworks.com. You could also follow me on Twitter. I love having followers on Twitter, and you can follow me at MagmaLemur on Twitter. Twitter. And you should totally buy Proton Pulse.
And you should totally buy Automation and Proton Pulse. Search for them on the store. You know what to do after that.
No, if you don't know what to do, it's buy them.
Okay.
I'm just gonna throw that
out.
You
all right.
should just buy them.
That's safe.
If you have an iOS device, and you like the show, there's no reason.
And check out CodingJar's tutorial thing. It's really cool. And if you have people who haven't touched Unity at all, it's great early beginner tutorial. So yeah.
Absolutely.
And it actually is pretty comprehensive. I very, very much liked it. So thank you very much, and have a great week.
Have a fantastic week.
Just always have to one-up me.
I do. Well, that's what happens when you go second.
It is.